Today, our objective is to be able to identify and write a hypothesis, a conclusion, and all the different logical statements we're going to learn today, including conditional, converse, inverse, contrapositive, and it's not listed, but biconditional. And you'll be able to justify your answers. We're going to try to go over the test tomorrow from the last 2 days. Not everyone's finished still, but we'll talk about it tomorrow. Today, we're moving forward. So y'all remember at the end of class, or most people yesterday were able to do that magazine assignment. Okay, that was kind of the intro into this. And you should have already written down the counterexample definition right here, and then answered 1 through 3. If you didn't do the magazine assignment yesterday, you'll have some time after the notes today, and then we'll start an assignment. So let's go back, and here we are. So a counterexample is an example that proves a statement is false, okay, or a conditional statement. So for example, if I say, if I'm Mr. G, then I'm the principal at Lee High School, is that true? No. So you would give me the counterexample of, well, true, I'm your teacher, not your principal, but a good counterexample would be someone who is the principal that's not Mr. G. Do y'all know the principal's name? Ms. Franco, thank you. All right. Yeah, so a counterexample of that statement, if I'm Mr. G, then I'm your principal, false. Ms. Franco is the one and only principal right now. So that's what a counterexample is. So let's try 1 through 3 real quick. Number 1, okay, we're going to determine true or false, and if it's false, give a counterexample. So on number 1, if a figure is a square, then it has 4 sides. True or false? True. So there's no counterexample needed. If a figure has 4 sides, then it is a square. Okay. So just because it has 4 sides doesn't mean it's always a square. So yeah, that's false. And you would give me 1 counterexample to prove that. What's a counterexample? Okay, so a rectangle is not always a square. So a rectangle would be an example. There's other ones. What else? What are some other examples? Trapezoid, parallelogram, rhombus, kite. Okay. Number 3, if 2 different lines intersect, then they intersect at 1 and only 1 point. Now, just so you know, we're not doing any more spherical geometry this year, so normal flat geometry. Okay. If 2 different lines intersect, then they intersect at only 1 point. True or false? True. Okay. All right, so down here at the bottom, or middle page, a blank blank is a statement that can be expressed in an if-then format. So that's what we did on the magazine thing, and it's the heading right here, a conditional statement. Okay, a conditional statement is a statement that can be expressed in if-then form. Off to the right, we have the symbols. Okay, so you want to notice these symbols. It looks like it says P arrow Q, but the way you say it, right below it, P implies Q, or if P, then Q. Those are the ways you would say it. Okay, that's a conditional statement. So anytime you see an if-then statement, that's conditional. Now, a conditional statement has 2 parts, after the if and after the then, right? So the first part, after the if, is called the hypothesis. It follows if. Okay, so P stands for hypothesis. And the blank of a statement is the part that follows the then. That would be the conclusion. Now, sometimes people get these mixed up because the hypothesis is not always at the beginning. The conclusion is not always at the end. What's important is what it says here. Follows if or follows then. Okay? So let me show you what I mean on these examples on number 4 and 5. So on number 4, it says, and we're going to do what? Underline the hypothesis, circle the conclusion. So 4 says, if two lines are parallel, then they never intersect. So what should I underline as the hypothesis? Two lines are parallel. Because I see if, and I underline right after it. Okay? And then what should I circle for my conclusion? They never intersect. So that's my P. That's my Q. Okay, and is that true? If two lines are parallel, then they never intersect. That's also a true statement. So cool. All right, 5. I'm going to put a star right here because this is the one most people miss. Okay, I want you to notice the first word in this sentence is not if. So we're going to keep reading until we see an if. Lines are perpendicular if, there it is, they intersect at 90-degree angle, at a 90-degree. So what do you think we should underline? Okay, good. It's the latter part of the sentence. If they intersect at a 90-degree angle. My P is now at the end of the sentence because that's where my if was in the middle. So that means the very first part of the sentence, even though there's no then, but you still circle the first part of the sentence. Lines are perpendicular. All right, and it's still true even if you switch the order. We do that all the time. Okay, in English we can move things around and still understand the statement. Okay, so like for example, if you're in Mr. G's class, then you're in M201. You can switch it around. You're in M201 if you're in Mr. G's class. Okay, you can switch around the order and it's still true depending where your if is. If the if goes with your hypothesis to the end of the sentence. Okay? Now, bottom down here, we have an example and it says if two angles form a linear pair, then they are supplementary. I really want you to remember a linear pair looks like this, touching. Supplementary do not have to be touching, okay? Right, so linear pair are adjacent because they actually are touching. Supplementary can be touching, but they're not always touching, okay? So here's the question, is this true? If two angles form a linear pair, then they are supplementary. So remember, supplementary just means they add up to 180. Linear pair add up to 180 and are touching, okay? So this is actually a true statement. If it's a linear pair, that means it does add up to 180, because that's what a straight line is, right? So this is true. Okay. So we've done the first page of these notes, and I want you to remember the name of this. What is this called? If P, then Q. Okay, conditional statement. This is what we just did. We spent the first page talking about the original conditional statement. Okay? So, let's go over here. Okay? Now I'm going to have to throw in myself here, so let me try to minimize this a little bit. Widget mode. Alright. So there I am. Alright. So we'll use that in a second. This says use the following conditional statement. If two angles form a linear pair, then they are supplementary. Let's learn what a converse is. Okay? So we're going to take our conditional statement and do something with it. Okay? So a statement formed by interchanging the hypothesis and the conclusion of a conditional statement. So notice this word right here. So converse is an interchanging, okay, which basically means they switch. So that's going to be our key word for converse, switch. Okay. Now, if you were not in Mr. G's class, maybe if you were even not at Lee, and you heard the word converse, what would you think of? What? Shoes. All right. So it's a brand, right? Boom. So converse make me think of shoes. So this can help us remember this, because we need a good way to remember. Okay. So I'm going to debut here. Let's see if I can get this to work. Okay. Well, there I am. So check it out. I got P and I got Q, right? So a normal conditional statement is if P, then Q. Okay? So converse is going to take P and Q, and our keyword was switch, right? So we're going to just do this. If Q, then P. All right? So I'm going to use this conditional statement for the rest of the class. Okay? So get used to this one. If I'm Mr. G, that's my hypothesis, then I have long hair. Okay? So if I'm Mr. G, then I have long hair. What is the converse of that statement? Okay? Well, so if I'm Mr. G, then I have long hair, switches and becomes, if I have long hair, then I'm Mr. G. Now, it doesn't matter if it's true or false. The point is you just switch it, and that's the converse, okay? Now, we can ask the question, is that true? So, is it true that if you have long hair, then you are Mr. G? No, because you could be anyone in this room, anywhere in the world, and have long hair, and you're not me, right? But that's the converse. It just switches, okay? So, here's what I want you to do. This is interactive. So, I want you to hold up your hands like this, like you're going to give 2 high fives, okay? And I want you to, I want you to think about, so like I said, outside of class, I think of Converse shoes, and let's say I gave you everybody an invisible pair of Converse shoes. They're just not laced, right? So what you got to do is you got to take those laces, and you got to do this. Start lacing them. You got to switch them over, right? You got to, okay? But think of shoes, think of laces, think of over, okay? That's how you can remember what a converse is. They have to switch, okay? So again, converse, lace, whoop, that's what you do. So let's do another one. So Mrs. Marrero has an example. If I'm Mrs. Marrero, then I sing. Math songs. We'll stick with sing. If I'm Mrs. Marrero, then I sing. So what do I do for converse? Do it. Whoop. So what's the converse? If I sing, then I'm Mrs. Marrero. Okay? So again, all we did for converse is take P and Q, switcheroo. Okay? So we need to write a sentence based on this top sentence way up here, right here. So we're going to take the sentence, if 2 angles form a linear pair, then they are supplementary. Let's switch it. What's my new sentence going to be? So this sentence right here, if okay, so if it's always there we go. If what's the switch? Okay, good. If they are supplementary, I'm going to abbreviate because I'm going to run out of room. If they are supplementary, then 2 angles form a linear pair. Okay? So does everyone see what I did there? Notice the symbols. P arrow Q becomes Q arrow P. All it did was switch. The way we say it is P implies Q became Q implies P. So I want y'all to think about now that new sentence, that converse, is it true or false? So think about 2 angles. If they're supplementary, if they add up to 180 degrees, then does that mean they're a linear pair? Okay. I heard 1 no. Anyone else? Okay. So this is false. So that's correct. Because, remember, if you have two angles that add up to 180, like 80 and 100, that doesn't mean they're adjacent. Doesn't mean they're touching. And they have to be touching to be a linear pair. Okay? So, again, that's my counterexample. Right here. All right. We get on converse. Okay. So the next one is inverse. Let's read it. A statement formed when both the hypothesis and the conclusion of a conditional statement are negated. Now, do y'all know what the word negated means? What does it sound like? It sounds like negative. Okay. Negating something like a negative sign makes it opposite, right? So let's say I'm Mr. G. What would the negation of that be? I'm not Mr. G, right? If I said I'm cool, the negation would be I'm not cool, right? So all that to say, negation just means opposite. Let's go ahead and write that down. Opposite, comma, but there's no switch. The order is the exact same, but everything is opposite. No switch. So if you look at the symbols, P, arrow, Q becomes squiggle P, arrow, squiggle Q. Now, I want y'all to know that that squiggly thing is not called a squiggle. I just said that, but it's called a tilde. It's on your keyboard. I'll show you. Up here at the top left, right around here. There it is. Well, not really. You usually have to hit shift, but let's get rid of that somehow. Okay. Well, it'll just stay there. So, those squiggles, the way you say it is not. Okay? So, not. So I would say not P implies not Q. Okay? The opposite of P implies the opposite of Q. Okay? So, let's do this again. I've got my papers here. So, this time, instead of, I'm not going to switch the order. All I'm going to do is flip them around, and now I got not P implies not Q. Okay? So, if we were to do this with our hands, so everybody, all right, invisible high fives or visible high fives, either way. Okay, take your hands and instead of, we're not converse, we're not going to switch them. Inverse, you're going to take your palms and put them inward. Inverse, inward. Meaning, it's just opposite, the opposite direction, right? So it looks like an invisible double slap, but don't do that, right? So all you're doing is opposite of P and Q. So let's take the example again. If I'm Mr. G, then I have long hair. All right? What's the opposite of if I'm Mr. G? If I'm not Mr. G, what'd you say? Did you say Mrs. G? That's funny. All right. If I'm not Mr. G, then what? Then I don't have long hair, or you could say I do have short hair. Either way, right? Whatever is the opposite. Let's try another one. If I'm Mrs. Marrero, then I sing. What's the inverse? If I'm not Miss Marrero, then I do not sing. See how that works? Same order, opposite. Okay? So recap. Conditional statement, converse is a switch, inverse is the opposite. Okay? Let's write this down. I keep losing my marker. It is. Found it. Okay, so let's do this. Okay. Actually, I know that's going to mess it up. There we go. Here we go. So, I'm going to take that original statement up here at the top. If two angles form a linear pair, then they are supplementary. What is the inverse going to be? Okay, so I'm going to take two angles form a linear pair. The opposite is two angles do not form a linear pair, right? Very good. So if two angles, I'm going to put don't, contraction, don't form a linear pair, again, abbreviating a little bit, then I need to negate they are supplementary. What's the opposite of they are supplementary? They are not. Supplementary. I'm going to abbreviate that too. Okay? So if two angles don't form a linear pair, then they are not supplementary. So this one's the hardest one to visualize, okay? So I want you to think of two angles that don't form a linear pair. Okay? Now, if it doesn't form a linear pair, that means it could be two supplementary angles that are not touching. Okay? So here's an example of two angles that are not a linear pair because they're not touching. But does that mean they are not supplementary? False, because this is a counterexample, okay, where these are not linear pair, but they are supplementary. Okay, so this is false, and it's the same counterexample. Okay, so we've done converse, inverse. Now we have contrapositive. If we've done switch and if we've done opposite, guess what we can do with both of those steps? Combine. Yes, we're going to do both. So contrapositive. That is a long multisyllabic word. So think about the big one, the weird one. That takes two steps. Okay? Contrapositive. A statement formed when the hypothesis and conclusion of a conditional statement are both reversed and negated. So this one is both steps. So I'm going to put switch and opposite, or switch plus opposite. You have to do both steps when you're doing contrapositive. And you look at those symbols. P implies Q now is not Q implies not P. The opposite of the conclusion implies the opposite of the hypothesis. Okay? So, again, let's think about this. If I got my original statement, P implies Q, okay? My contrapositive is going to be two steps. Is everyone looking right here? I'm going to switch and negate. Okay? So now it's not Q implies not P. Okay? So you don't have these, but you have hands. So can I see y'all's hands, palms, right? All right. So here we go. To do contrapositive, you're going to do two steps. And it's going to look like a dance move. Okay? You're going to switch and negate. Don't hate, just switch and negate. The faster you do it, the cooler you look. All right, so let's do an example. Okay, here's my same example. If I'm Mr. G, then I have long hair, right? If I'm Mr. G, then I have long hair. So take the last part, the long hair, bring it to the front, opposite. What's that going to be? If I do not have long hair, then take Mr. G to the end, opposite, then I'm not Mr. G. So, again, if that was too fast, if I'm Mr. G, then I have long hair, becomes, if I do not have long hair, then I'm not Mr. G. Okay? So, let's try another example. Okay? The same one from earlier. If I'm Mrs. Marrero, then I sing. What's the contrapositive? If I don't sing, then I'm not Mrs. Marrero. True for me. All right, but that's a contrapositive. Two steps. Okay? So let's try that with the original example. If two angles form a linear pair, then they are supplementary. Okay, let's write our contrapositive. What would my contrapositive be? Okay. Okay, if they are not supplementary, right? So the opposite of the Q, then two angles don't form a linear pair. Okay, now we want to think, is this true? So think about two lines. If they're not supplementary, they don't add up to 180. So does that mean that they won't form a linear pair? What do you think? True or false? What do you guys think? Any of you guys think about this? If they are not supplementary, then they don't form a linear pair. True or false? Okay, not supplementary means they don't add up to 180, right? So can something that doesn't add up to 180 make a linear pair? Okay. And that's the only way it can be, right? If they're not supplementary, they're definitely not going to be a linear pair because a linear pair has to be a straight line. It has to be 180. So this is a true statement, okay? Not supplementary means not linear pair, okay? All right, we got one last thing, and that's biconditional. We know the prefix bi means two, right? And basically a biconditional statement is true two ways. Okay, so when both the original, conditional, and its converse are true, you can write a biconditional. Notice the symbols. How is the arrows different now? Right, the arrow goes both directions, okay, because it's true both ways, okay? My example would be if I'm the teacher most of the day in M201, then I'm Mr. G. That's true. And if I'm Mr. G, then I'm the teacher most of the day in M201. That's true too. Both ways, the original and the converse, they both are true. I could make that a biconditional statement, okay? But notice the phrase. You have to know this. We use the phrase if and only if. That's the new phrase for biconditional. Instead of if or then. The if and then go away, and instead you put if and only if in the middle of the sentence between the P and the Q, between the hypothesis and the conclusion, right? So here's an example. You would say two angles are supplementary in the middle there, if and only if their measures sum to 180. That's true both ways. Supplementary adds up to 180. Adds up to 180 means supplementary. It's a biconditional statement. All right? So let's write two biconditionals, and that's it for these notes. On number one, it says if an angle is acute. That's my hypothesis. That's my P, right? Then it measures less than 90 degrees. That's my Q. Backwards, if it's less than 90, then it's acute. That works too. They're both true. So here's what I do. I drop the if, I drop the then, and I'm going to write if and only if between those two statements. So I'm going to start with an angle. No if. An angle is acute. Here comes my new phrase. If and only if it measures less than 90. What's my P on number two? Today is Thursday is my P. What's my Q? Tomorrow is Friday. So what am I going to get rid of? If and then go away, and I'm going to write today is Thursday. By the way, today is Thursday. That means tomorrow is Friday, and backwards. If tomorrow is Friday, then today is Thursday. Same thing. So that's an if and only if by conditional. Okay. So that's it for these notes. You're going to use them on the assignment I'm going to pass out, but I want to make sure if you have not done the magazine assignment from yesterday, okay, the magazine assignment, you need to do that real quick. It's just cutting out an ad, writing an if-then statement, taping it onto the piece of paper, and turning it in. It should be a fairly easy 100, okay? And then you're going to work on this conditional statements practice. You will have tomorrow as well. And we're going to have a quiz on Monday over this logic conditional stuff. For the magazine thing, here are the instructions on the front board. So if you didn't get to do it, you can look at the front board for the instructions. Everyone needs to be working until the bell, please.